I have a geometric sequence here. Now, how do I know it's a geometric sequence? Well, when I look at the sequence and I'm trying to find a pattern, and I look at any two consecutive terms, and I do the second of those divided by the first of them, I find that there's a common ratio. So we call this a common ratio. So for example, I can see that to go from here to here, I am actually multiplying by 12 over 4. Okay, and here will be 36 over 12. And what you notice is 12 over 4 is actually the same as 36 over 12, which is 3. Okay, so I'm actually multiplying by 3 each time to get from one term to the next term. Okay, so this makes this a geometric sequence because this common ratio is the same. Now, we will talk about how to find the nth term or the position to term rule in this sequence. Okay, so we are going to use this common ratio, and we're going to use the first term as well. Okay, so we're going to use the notation un, and let's think about how we get from the first term to the fourth term. Okay, so I'm going to call the first term a. So this is going to be a for me. And then this is the fourth term. Now I can see the first term has been multiplied by 3 times. So there's 3 jumps here to get to the fourth term. Okay, so to get to the fourth term. So to get to the fourth term, what I can do is I can have my first term, 4, and I need to multiply it by 3 cubed. Okay, that's to get to the fourth term. Now to get to the fifth term, I would have had 4 times 3 to the power of 4 because there's 4 jumps to get to the fifth. Now let's go to the nth term. Okay, so if I go to the nth term, let's say there's some gap here. Now, to get to the nth term, the number of jumps I'm going to need is 1 less than the position here. Because the number of jumps I needed to get to this one was 4. It was 1, 2, 3, 4. This is the fourth term, and I needed 3 jumps. 1, 2, 3. It's always 1 less than the position. Okay, so if the position is n, then the number of jumps I will need is 1 less than n, which is n minus 1. Okay, so that's what I need to raise the power to for the common ratio. So if I have a, which is the first term, so I put a here, and I need to multiply that by r to the power of n minus 1. I'm just going to show you that this does in fact work for some of these. Okay, so if I want to find the second term, let's say, so if I go the second term, well, the first term is 4, I know that, so 4, times, common ratio is 3, so 3, and second term, that will be 2 take away 1 here, so 2 take away 1, so I just substitute 2 for n, and 2 take away 1 is 1, so 4 times 3 is 12, and that is what I have in my sequence. Okay, to get to the third term, what I would have is 4 times 3 to the power of 3 take away 1, and that is 4 times 3 squared, because 3 take away 1 is 2, 3 squared is 9, 4 times 3 is 36, and I can see that that's what I have there. Here I have another geometric sequence, and I need to find the 10th term. So what I'm going to do for this, I'm going to first find the nth term, and then find the 10th term. So first I need to find the common ratio. So common ratio, I notice, is half. Okay, so I'm multiplying by half each time. So in that case, my nth term, un, would be the first term, a, which is 96, times half to the power of n minus 1. Okay, so I need n minus 1 jumps to get to n from 96. So if I want to find the 10th term, what I will do, I will write u10 is equal to 96 times half to the power of 10 take away 1. Now 10 take away 1 is 9, so I'm going to do 96 times half. I'm just going to do that on the calculator now. To the power of 9, and that gives 0.1875. So what I have now is that first geometric sequence which I made into a series by adding them up, okay? And now I'm showing you a formula to find the sum of the first n terms of any geometric series. Okay, so I'm going to show how to do this using the sum of the first 10 terms of this series. So I'm just going to substitute into this formula. A is your first term and R is your common ratio. So it will go like this. So S10 would be, A is 4, so 4 times 1 take away. Common ratio here was 3. Okay, so 3 to the power of 10. And then this is going to be divided by 1 take away 3. Okay, you'll put this in your calculator, and what you will get is 118,096. Okay, so this is how you find the sum of the first n terms of a geometric series. Okay, so you just use this formula, and you will find this formula in the A-level formula booklet. Again, I have a geometric series here. So here you can see that the common ratio is to multiply by half. And I need to find the sum of the first 4 terms and the sum of the first 10 terms. Okay, so I'm just going to use the formula for that. So the sum of the first 4 terms would be the first term, so 96, multiplied by 1, take away, common ratio to the power of 4. So common ratio here is a half. So half to the power of 4, and I need to divide this by 1, take away a half. Okay, put this in your calculator and you will find that you get 180. To check this, just add these numbers up, these first 4 terms, you will find that it is also 180. The 10th term, or the sum of the first 10, would be 96 multiplied by 1, take away half, to the power of 10 this time, and divide that by 1, take away a half. Okay, and for this one you will get 191.8125. Here are some questions for you to do. So there's a geometric sequence here. You need to find the nth term, so un in terms of n. Then I'd like you to find the 20th term. Then I'd like you to find the sum of the first 8 terms of the geometric series that has these numbers, okay, and then do it for the sum of the first 100 and the sum of the first 1,000.